7th, 2001. Al-Qaeda operatives hijack and crash 4 U.S. commercial planes, bringing down the World Trade Center towers and damaging the Pentagon. Just 2 months later, it appears that the unthinkable happens again. November 12, 2001. American Airlines Flight 587 mysteriously falls from the sky shortly after leaving JFK Airport. It crashes into a residential neighborhood in Queens, New York. All 260 passengers and 5 people on the ground are killed. The FBI and investigators from the National Transportation Safety Board quickly mobilized to determine the cause.
We assembled a team of probably 15 people to immediately fly up to New York and begin the investigation. It was impossible, really impossible not to at least at some level, assume that it might not have been an accident and it might have been a terrorist act.
The FBI found no obvious evidence of terrorism at the crash site. But investigators for the NTSB uncovered a vital clue that suggested a mechanical failure.
The vertical stabilizer was located in the water in Jamaica Bay, about a mile from the accident site. We knew that some part of the aircraft structure had failed, and our big job was to figure out why.
To lose a vertical fin is a pretty serious situation. It makes the airplane very difficult to control, if not impossible. In this case, apparently impossible.
An aircraft's vertical stabilizer, which includes the rudder, provides lateral stability during flight. Take it away, and the airplane will wallow from side to side, lose altitude, and crash. Flight 587 was on an Airbus A300-600 aircraft. The vertical stabilizer had a unique quality. It was manufactured from composite material, layers of carbon fiber that provide a lightweight alternative to aluminum.
And we saw the 6 lugs made up of composite material broken. The rest of the fin, the composite fin, was in the bay. The lugs that were supposed to hold it on were there, but they were cleanly broken off.
The investigation team soon made an equally important discovery. They recovered Flight 587's flight data recorder and its cockpit voice recorder. With these key pieces of evidence, NTSB investigators embarked on the lengthy process of determining what caused the vertical stabilizer of Flight 587 to fracture. They started by scrutinizing the structural integrity of its composite material.
We tested it down to the micro level, so to speak, by pulling bits of it apart, make sure it was strong enough. We concluded that the design of the structure was satisfactory, and in fact, the strength of the material was stronger than it was designed to be.
Investigators then turned to analyzing Flight 587's voice recorder, a key piece of evidence, allowing them to eavesdrop on the pilot's final words.
When we listened to the voice recorder, we heard the captain mention wake turbulence. Then we went back to the recorded radar data, factored in the winds, and proved that indeed he did run through this wake turbulence.
Wake turbulence is rough air that forms from the wingtips of airplanes. Studies show that wake turbulence resembles a horizontal tornado. When encountered by another aircraft, the vortex causes the wings of that aircraft to dip down or bank.
It was immediately evident that wake turbulence in itself couldn't have caused this accident. For one thing, there was 5 miles of separation. For another thing, the airplanes were already well established in the climb, and that means that they were going at a pretty good speed. The strength of turbulence diminishes as speed increases, and so it just didn't make any sense.
Having ruled out wake turbulence and the vertical stabilizer's composite material, the investigation shifted again. NTSB officials conducted interviews to determine the competency of the co-pilot, who was commanding the aircraft when it crashed.
This one gentleman was a captain in a Boeing 727 when the accident first officer was his first officer. They ran into a bit of wake turbulence, and the first officer reacted strangely. In a sense, he activated the rudders back and forth several times, causing the aircraft to yaw quite heavily.
Fully deflecting the rudder back and forth as the co-pilot had done stood out as a red flag to investigators. An analysis of Flight 587's data recorder showed that the co-pilot had once again repeated this abnormal maneuver.
He jumped the gun on responding, and that as the airplane swung one way, he came in with opposite rudder, and that the airplane then swung back and overshot in the other direction because he had put in too much rudder control. And so he then went to the other rudder pedal and tried to correct this.
This led to a shocking revelation, dispelling any theory of a terrorist plot, that a pilot could inadvertently cause severe structural damage to an airplane at maneuvering speed.
Maneuvering speed is a speed below which, in the general understanding of pilots, any deflection of the controls can be made with any speed, any violence. The plane can be maneuvered in any way you choose without endangering the structure. However, it turns out that there was some fine print in the certification of airplanes, and one of the provisions in the fine print was essentially that you couldn't flap the rudder back and forth the way this pilot allegedly had done.
The A300-600 was somewhat susceptible to this type of anomaly. At the speed the aircraft was traveling, about 250 knots, it only took about 1 1/4 inches of rudder travel to move the rudder all the way to 9.3 degrees either way, and it only took about 32 pounds of rudder pedal force. And it takes 20 pounds just to get the rudder to move, so there's not a lot of margin there at all.
Good morning, Madam Chairman and members of the board. I'll be discussing...
The final report issued by the NTSB fell short of citing the Airbus A300-600 rudder sensitivity as a design flaw, but it did recommend that future Airbus planes incorporate a fail-safe mechanism that will prevent a pilot from critically damaging the aircraft. As of 2006, Airbus has yet to modify its A300-600. Nevertheless, since the crash of Flight 587, the Airbus rudder system has performed flawlessly.
This type of accident has never happened before. It hasn't happened since the accident, and we would hope it would never happen again.
Flight 587 is the second American Airlines jet to crash shortly after taking off from JFK. It's also the second to crash from rudder failure. In 1962, American Airlines Flight 1 crashed into Jamaica Bay after a wiring failure caused its rudder to deflect uncontrollably. Engineering disasters will return on Modern Marvels.